All right, welcome to the next page of problems. That joke only makes sense if you saw the end of the last video and then immediately clicked on this. So number 46 is the limit as x approaches negative infinity. Okay. Oh, sorry. X approaches infinity. Okay. 3x squared plus 11 over x cubed plus 2x squared plus 18. Okay, so now this, if you took college algebra, either with me or maybe without me, but if you took college algebra recently here at USF, in USF Tampa specifically, you would remember like, oh, yeah, the numerator has a bigger power than the denominator, so that means it's just going to go to 0 at the endpoints, right? And you'd be right. Okay, but now we're going to look at it just a little bit differently, a little bit different take on it. It's going to get the same answer, but we're going to be able to do more with this new way of thinking about it, okay? So we're going to go ahead, we're going to factor out the highest power of x that appears in the denominator. Okay, so when we factor out the highest power of x that appears in the denominator, that means in this case it's x cubed. Okay, so we're going to get the limit x goes to infinity, and so x cubed, and in the numerator we're going to have 3 over x plus 11 over x cubed. Okay, in the denominator we're going to have, factoring out an x cubed, 1 plus 2 over x plus 18 over x cubed. Okay, so now those x cubes cancel. I'm just writing it out again without the x cubes. Now, what happens to 3 over x as x goes to infinity? That becomes 0, right? So all of these terms become 0 except for that 1. So you're going to get 0. Okay? We're going to do the same. We're going to play the same game with, let's play the same game with 41, okay, or 42. Okay, 42 states, I had skipped that one, I was supposed to do that one. Limit as x approaches infinity, x squared minus 3x plus 7, 3x squared plus x plus 15. Excuse me just a second. Thank you. Okay. So we're going to do the same game. We're going to factor out the x squared in this case because that's the highest power of x in the denominator. Here it was x cubed. Here it's going to be x squared. Okay, so we're going to take the limit as x approaches infinity, factoring out the x squared, 1 minus 3 over x plus 7 over x squared. Okay, so I just want you to recognize X squared times 1 is this x squared. X squared times 3 over x is this 3x. X squared times 7 over x squared is this 7. Okay. And then in the denominator, factoring out x squared, we get 3 plus 1 over x plus 15 over x squared. Okay. Now, same thing. We're going to cancel those x squareds. Okay. So canceling those x squareds equals 1/3. Okay, that's one of my favorite numbers, 1/3. Okay, next, let's do number 50. Same sort of thing. By the way, if you were in college algebra, okay, what I would have taught you there is said, oh, we've got the same degree, so you're just going to take the leading coefficients. In this case, it was 1/3 as your horizontal asymptote. Okay, 50. The limit as x approaches infinity, okay, of 5x cubed plus 2x squared plus 1 over x squared minus x plus 1. Same thing, we're going to factor out the highest power of x in the denominator. And again, it's x squared. Okay, so I'm going to skip a step. Don't worry, it's not so crazy. I'm just going to pretend we factored it out and canceled it. Okay, so we're going to get 5x plus 2 plus 1 over x squared divided by 1 minus 1 over x plus 1 over x squared. And what's going to happen as you take x going to infinity? Okay, well, we've got this 2. This is going to go to 0. This is going to go, both of those are going to go to 0. So you're going to get infinity over 1. Okay, so this one goes to infinity and beyond. Okay, just infinity. Okay, all right. Do one more problem on the next video, so I'll see you guys in the next video.